Okay, so far you have learned as to how do you find the mean, mode and median using Excel functions, right? Now what we are trying to learn is the measures of location, that is the mean, mode, median, are not enough, are not the only parameters that any of you should consider while making business decisions. Okay, so you might have seen a reference to the computer repair times in slide 11. So we'll just try to understand as to what exactly is happening over here. Okay, so here the first thing that we'll do is we'll try to find out the mean, mode, median, okay, for all of the data that we have. So just so you understand as to what exactly is this data pointing out to, so we have samples. For each sample there is a repair time. So these samples are basically the computer numbers, and the sample time is how much time did it take for the computer to get repaired. Okay, so let's find out the mean, mode and median. Okay, so let's find out the mean with the help of the average function. Okay, so this is my mean, this is my mode, this is my mean. So you see here all of these values came out to be almost 15. So that's around say 2 weeks, right? So if I tell a customer after looking at this specific data, if I tell the customer that it's going to take around 2 weeks for your computer to get repaired, right? So the customer will expect us to get back to the computer in 2 weeks, right? But when we look at the data in more detail, we'll find out this isn't true. Okay, so to do that, the first thing that we'll try to find out is to is the relative frequency, and the frequency as to how much time did it take for the computers to get repaired. Okay, this is already done in this specific Excel file which says histogram. You can always refer back to this specific Excel file, but what we'll do is we'll try to make our own Excel file so that you will understand as to how this is made. Okay, so the first thing that we'll do is we'll find out the minimum and the maximum number here. Okay, so minimum number of days, maximum number of days. To do that, we'll use the min function, and to find out the maximum we'll do the same. So we have minimum as 5 and maximum as 40. Okay, so we'll start with say 0 number of days and go up to 40. Okay, so let's make an Excel file, start counting from 0, 1, 2, 3 and so on, and we'll extend it up to 40 days. Sorry. Okay, so these are the number of days. Now the next thing that I have to find out is how many computers were repaired in these many number of days, right? Now when we look at this blankly, we wouldn't know as to how many computers were repaired in 0 days, 1 day, 2 day and so on, right? So what we'll do, we'll use the COUNTIF function, right? So by using the COUNTIF function, I can determine how many computers were repaired in these many number of days. Okay, so that's the range, and the criteria will be here, which is the number of days. Okay, but you see here I again forgot to put the dollar symbol. So you see the range is getting increased here. The range where the data is located is from B4 to B253, correct? But it's increasing now, say B5 to B254 and so on. So what we'll do, we'll just put the dollar sign, so we have the exact reference of the cell. Okay, once we do that, we can extend it down, and that is it. Okay, so these many number of computers, sorry, these many, yes, these many number of computers were repaired in these many days. So 12 computers were repaired in 8 days, and 20 computers were repaired in 14 days, and so on, right? So that's the frequency. Now let's find out the relative frequency here. We know how do we generally find out the relative frequency is by finding out the total first. So let's find out the total here. That's 250 computers. So we'll divide this by 250. Okay, so that's how we determine the relative frequency here. Cumulative percentage is nothing but just the percentage, the accumulation of things. So here this will be 0, here it will be what, this plus this, and that's how we find out the cumulative percentage. So this, make it a percentage value, and that's about it. Now we are just doing this so that we see that the measures of locations are not the parameters to always give you a reasonable solution. Okay, so let's plot this. So this is the frequency plot. By looking at the measures of location, we determine that, so when you look at this, we determine that maximum of the computers were getting repaired in 2-week period, correct? But when we look at the frequency distribution here, we see that there are a considerable number of computers getting repaired in 14 days, but there are still a lot of computers that are getting repaired after 14-day interval, right? So if you tell your customer that in 14 days the computer will be repaired and it will be good to go, right? But if the customer returns back and sees that the computer is still not ready, so you will get a non-satisfied customer, right? So at that time the frequency distribution helps, right? So at that time, since we are using frequency distribution, you can see here around 90% of the computers are getting repaired in the 21-day interval time, right? Let me just highlight it so that we all can see it better. So you see here in the 21-day interval, 90% of the computers are getting repaired. So instead of stating 2 weeks, we can definitely say that 3 weeks. So we know that 90% of the time it took 3 weeks for the computer to get repaired, right? So it's always better to use different kind of statistical analysis always, instead of putting your all efforts in one. So instead of just using the measures of location, that is the mean, mode, median, to determine as to uh, what is the average number and how I can quote the customer the number of days. Instead of doing that, I will use this specific technique of using a frequency distribution. So always just remember, in business analytics there is not one way to determine, not one model to determine any specific solution. There's always a combination of a bunch of things when it comes to business analytics.